Okay, so we have a class of 5 people, right? And it's kind of funny. They have first names Clark, Donald. This is Donald. Donald, yeah. Jack, Robin, Steve. Okay. And then, funnily enough, their last names are. Well, it's not the same last name for each person. So it's Clarkson, Donaldson, Jackson, Robinson, and Stevenson. So you add SON to the name, but they could be for different people. So it could be Clark Donaldson, Jack Jackson. You know, it can't. It might be Jack Stevenson, right? Okay. And then we're told Clark is 1 year older than Clarkson. Okay. Donald is 2 years older than Donaldson. Jack is 3 years older than Jackson.
Mm-hmm.
Robin is 4 years older than Robinson. And the question is, who's older, Steve or Stevenson? Okay, and by how much? So yeah, you might want to try this yourself before seeing how it might go. Okay, so have a pause or think about it. Now, no way. So then, okay. There's lots of ways you can try this problem. You might think, well, maybe Steve could be 5 years older than Stevenson. It's an absurd logic, but it does seem to follow the pattern. But then you might want to just think about that for concreteness and why it's not right. Okay. But straight away, like if Clark is 1 year older than Clarkson, then they're not the same person, right? And Donald is not the same person as Donaldson. Jack is not the same person as Jackson. Robin is not the same person as Robinson. And Steve, well, they could even be the same person, well, as far as you know. Or could they? Okay, so one thing you could realize is why can't they be the same person? Well, this person's older than that person, right? So they can't be the same person. Yeah. But this actual logic helps you solve the problem because these 5 people are actually the same 5 people here, right? So if every one of them is older, okay, then that's a problem because the same 5 people have to have the same total age as the same 5 people, right? You can't everyone be older than these other people. Because if Steve was older than Stevenson, then this group of people together would be 10 years or more older than this group of people, which is impossible, right? So actually Stevenson would have to be older than Steve by 10 to make it the same age. Okay. So that would solve the problem, but if you can't just see that straight away, there's lots of other things you can try to get the problem, okay? So one thing that you might learn as you go on when you do maths is there is definitely not enough information to figure out the ages of any of these people, okay? But as long as you come up with ages that work, it should tell you who's always going to be older and their age difference, okay? So there's not enough difference to tell the age, but you can tell the relative ages. So, we know that we can just pretend Clarkson, let's just say that Clarkson is the youngest. Just see if we can make up 5 people's ages that work, yeah? So let's just say Clarkson is 0, okay? So Clarkson's 0. And let's say Clark is 1 year older than Clarkson, so Clark is 1, yeah? Yeah. Okay. Then we say Donald is 2 years older than Donaldson. Okay. So Donald is 2 years older than someone. So let's make Donald 3. And then make it Clark Donaldson. Okay? Jack is 3 years, so this is Donald. Jack is older than someone by 3. Okay? So let's say Jack is 6. Yeah?
Mm-hmm.
It's older than Jackson. So let's say it's Don Jackson. Yeah. Okay. And then Robin is older than someone by 4. So let's say Robin's 10. Yeah. And older than Robinson. So let's say it's Jack Robinson. Yeah. Okay. So what is so let's see if these ages satisfy this problem. So we have Robin is older than Robinson, yeah. Jack Robinson. Jack is older than Donaldson. Jackson, sorry. And then Don is older than Donaldson, yeah. And then Clark is older than Clarkson. Okay. Yeah, so I guess the question is, where do we put Steve and Stevenson? Well, if we look at this, okay, these satisfy these conditions, and the last name here has to be Stevenson, right? And this should have to be Steve, right? That's the only way you can put it once you've got that. And this actually satisfies the conditions, right? It satisfies the conditions of all this. So you don't actually know this is like every way of satisfying the conditions should give you the same thing, but the way the problem is written suggests it does. So if you just want to know the answer, finding this works, and that would suggest Stevenson is 10 years older than Steve, right? Okay, and then you might be able to find the more elegant proof, but this will definitely give you the answer, if the answer exists. Okay, and then knowing that, it might help you figure out how that works. And then you might notice 10 is mysteriously the same as the sum of 6, 3, 1, right? Okay, alright.